Good evening. In today's session is an extra session. So we'll discuss about questions from all the previous sessions. And my actual session is tomorrow at 7 p.m. So this is just for discussing all the content from the last few. Okay. So basically, I'll be asking uh, some questions based on the contents from the previous weeks. So you can post your answers in the chat. So a grayscale image has a resolution of 28 by 28 pixel. If the image is unrolled into a vector, what is the dimension of that vector? 28, 56, 784, 1024. You can post your answers in the chat. Yeah, so unrolling a 28 by 28 image means you multiply the rows and columns, which is 28 and 28. So it is 28 by 28, which is equal to 784. So each element will become so each of the pixel from this 28 by 28, that will become an element of the vector. So there is a vector x1, x is equal to x1, x2, x3, x4, x5. These are the elements of the vector. Then what is the dimension of this vector x? So the dimension of a vector is the number of components it has. And in this case, the vector x has 5 components, x1, x2, x3, x4, x5. So the dimension of this vector is 5. Vector itself is a first order tensor, but dimension refers to the number of elements in the vector. So the answer is 5. What do you mean by number of features? So this vector corresponds to one feature. So suppose if I have a data set where I have age, gender, etc. are the features, then 20, 30, 40, female, male, female. This is a one-dimensional array, right? So this is a vector. This is another vector, which is another one-dimensional array. And it has how many components? It has 3 components. So the dimension of this vector is 3. Similarly, for this one, it is 3. It is what is asked here. It's not the number of features, it's just the values, the elements of a vector. Next question, which of the following is a tensor of order 3? Which of the following is a tensor of order 3? A scalar, a vector, a 2 by 2 matrix, a 32 by 32 by 3 image. Yeah. So a tensor is any higher dimensional array. So if a tensor has an order 1, then it is called as a vector. If a tensor has an order 2, then it is called as a matrix. If 2 or more, then it is higher dimensional. So here 3 is asked. So it is 32 by 32 by 3 image. It could be m cross n cross p. It could be a 3-dimensional. That is what is asked. So the answer is 32 by 32 by 3 image. So order is the number of indices needed. A scale. So what will be scalar? The order of a tensor of order 0 is scalar. A tensor of order 1 is a vector. Order 2 is a matrix. So if we take this 32 by 32 by 3 image, it has that means it requires 3 indices. That is the order. This is the rows, columns, and the channel. When you have a RGB image, you have 3 channels. That is what it is. So this is a third order tensor. A vector has six components. What is its order and dimension? Order is 6, dimension is 1. Order is 1, dimension is 6. Order is 2, dimension is 3. Order is 3, dimension is 2. So vector is always a first order tensor. As I have mentioned here, a tensor of order 1 is vector. And here we have, for the vector, it has 6 components. So order is 1 and dimension is 6. So there is an audio signal and it is sampled at 16,000 hertz for 3 seconds. And this is stored as a vector. What is the dimension of that vector? So an audio signal is sampled at 16,000 hertz for 3 seconds. What is the dimension of that vector? Yeah. So the number of samples here, sampling rate into duration. So sampling rate is 16,000 hertz, so 16,000. Duration is 3 seconds, equally 48,000. So this much data, this is flattened into a vector. So the dimension of that vector will be 48,000. So a dataset of 200 videos has 30 frames per video. Each frame is 64 by 64 pixels with 3 RGB channels. What is the tensor representation of the dataset? So then what is the tensor representation of this data set? So the standard representation is you have a batch and then you have the time, that is 30 frame, and then you have the height and the width of the image, which is 64 by 64, and then the number of channels, which is 3. So there are 200 videos and each of them have 30 frames and each frame is 64 by 64 and there are 3 RGB channels. So example B. Yeah, so to add two matrices, is it same number of rows, same number of columns, same number of rows and columns? Any size is allowed. Should be same number of rows and columns. If A is equal to 1, 2, 3, B is equal to 4, 5, 6, what is the dot product? So the dot product is just multiplication and then sum. So 1 into 4 plus 2 into 5 plus 3 into. Each expression correctly represents the dot product A dot B using the matrix notation. Yeah, so which expression correctly represents the dot product? It is um, A transpose B. This is how typically dot product of two vectors is written as. Would be A transpose B. AB transpose is outer product. It's not a dot product. The output here, the output will be a scalar value, a single value. But AB transpose will have, it's not a scalar. The result will be a matrix, and this is the outer product. Suppose if I have, I'll show one example. Suppose if A is equal to 1, 2, and B is equal to 3, 4. Okay. So suppose if I take A transpose B, then I will have 1, 2, 3, 4, 5. So then I will get 1 into 3 plus 2 into 4, which is 11. So this is a scalar value. Whereas if I take A B transpose, then A 1, 2, and 3, 4. So this will result in 3, 4, 6, 8. So this is the matrix. This is the outer product, and this is the scalar value. This is the dot product or the inner product. This is the outer product. So the answer is A transpose B. So what is tensor vector B belongs to R8, and this is mapped to U, which belongs to R3 via a W. V is equal to U transformation. What must be the size of W? What must be the size of W? 8 by 3, 3 by 8, 8 by 8, 3 by 8. Oh, I mean audible. A sensor vector V belongs to R8 is mapped to U. R3 via WV is equal to U. What must be the size of W? 8 by 3, 3 by 8, 8 by 8, 3 by 3. So this is W. The transformation is WV is equal to U. It's given V is V belongs to R8 and U belongs to R3. That means V, the size of V is 8 by 1 and the size of U is 3 by 1. So W into V is 8 by 1 is equal to U is 3 by 1. And this is sum n by n. So if this has to work, then what should come here? 3 by 8. Then only this multiplication will give this right hand side. So 3 by 8 into 8 by 1, this is the common. So this will give 3 by 1. This is the same as this. So the answer is 3 by 8. Let's see one more similar question like that. A robot collects 12 sensor readings mapped to a 4D vector via y is equal to w. What is the size of w? Yeah, so just like before, y is wx, y is 4 by 1, x is 12 by 1. So this must be 4 by 12. So A is a 4 by 3 matrix and the vector B is 1, 2, 3. The row vector. What is the size of A plus B using both parts? A is a 4 by 3 matrix and B is 1, 2, 3. What is the size of A plus B using both parts? Yeah, so here to each row of A, this 1, 2, 3 will be added. So it will be the same. It will be 4 by 3. The size will be 4 by 3. So select this one. 8 rows. So these are so this is the 4 by 3 matrix. Now to this one, to each of the row, you will add B. So that is 1, 2, 3. You will add to this one, and this one. So the size will be the same, which is 4 by 3. This condition defines the inverse of the square matrix. A inverse is 0, A inverse is A inverse is A plus A inverse is I. So we already know this, that the inverse satisfies A times A inverse is equal to A inverse A is equal to I, where I is the identity matrix. For V is equal to 3, 4, what is 2 of V? So the Euclidean norm is given. So suppose if V is equal to V1, V2, the Euclidean norm is given by, as we know, this is square root of V1 square plus V2 square. So the same thing has to be applied here. So square root of 3 square plus 4 square, which is square root of 25, which is 5. For V is equal to minus 5, 3, 2. What is now 1? Then that means for V is equal to minus 3, 2. What is now? What is the first norm of the L1? So the L1 norm is the absolute sum. So if V is equal to V1, A2 is there, then it will be the absolute value of V1 plus the absolute value of V2. So here it is the absolute value of minus 5, which is 5, then 3 plus 2, so it is 10. So for the same V, what is infinity? The infinity norm is the maximum of the absolute values. So it is the maximum of absolute value of -5, absolute value of 3, absolute value of 2. So this is 5, 3. So that answer is 5. So A is equal to 1, 2, 2, 0. What is the Frobenius norm of A? 3, 5, um, 8, 9, 14. So Frobenius norm is square root of sum of squares of all elements. Square root of sum of squares of all elements. So that is square root of 1 plus 4 plus 4 plus 0. So that is square root of 3. It is equal to 3. So it is A. Mm, let me see. What is the span of 1, 0, 0, 1, R3? A single line, a plane, the whole of R2 upon. What is the span of 1, 0 and 0, 1 in R2? So 1, 0, 1, 0 and 0, 1. These are the standard basis vectors of R2. That means you can generate every possible vector in R2 using 1, 0 and 0, 1. So that is if you have, so this is your R2 and this is 1, 0 and this is 0, 1. If you rotate this, you can generate every other vector in R2. So the answer is the span of 1, 0 and 0, 1 is these are the standard basis vectors of R2. So it will span the whole R2. It's alpha 1 V1 alpha 2 V2 equal to 0. That's only the solution. Alpha 1 is equal to alpha 2 is equal to 0. Then the vectors are linearly independent, linearly dependent, parallel, none of the above. If alpha 1 V1 plus alpha 2 V2 if 0 has this only one solution, alpha 1 is equal to 0, alpha 2 is equal to 0. Then the vectors are so they are linearly independent because vectors are linearly independent. It's the only way to express the 0 vector as their linear combination is by making alpha 1 and alpha 2 as 0. So it is linearly independent. Are the vectors 1, 2 and 3, 4 linearly independent? True or false? Yeah, they are not linearly independent because one is a multiple of other. So you have 1, 2. If you take this 1, 2 and multiply it by 2, then you get 3, 4. So they are linearly dependent. That also means what will be the span of this? Is it R2? Is it a line? Is it a point? So then it will be a line because this is that R2 and 1, 2 will be this vector 1, 2, this vector 2, 4 will be this vector. Then I will follow I didn't draw it properly, but it is a line. So for a 3 by 5 matrix, what is its stretch? For a non-square matrix M by N, it is the sum of the elements. So if uh, 3 and 5 are there, you take the minimum, so it is 3 and 5. Take the minimum number, which is 3. So then take the uh, sum of that many diagonal elements. So that is the case for a non-square matrix. A is equal to 2, 4, 1, 2. What is the determinant of A? 4, 8, 0, 8. So it is 0. It is AD minus BC and this is AB, CD. So 2 into 2, 4 minus 4. If one vector in a set of 3 vectors in R3 is a linear combination, put the other 2, then for the matrix A formed by this vector, determinant of A is greater than 0, determinant of A is less than 0, determinant of A is equal to 0, trace of A is equal to 0. Yeah. So if vectors are linearly dependent, that means its determinant is equal to 0. It will form a matrix that is singular. So the linearly dependent column means there are some things in common and it will result in a determinant that is 0. A matrix is symmetric if A is equal to A transpose. So the eigenvectors of the matrix A are special because they remain completely unchanged under A. They only rotate under A. They only stretch under A. They always move to 0. So A B is equal to lambda B. This is the notation for eigenvector by definition. So this means the matrix A will only scale the eigenvector V. So the matrix A will only scale the eigenvector V by an amount lambda. So the direction is preserved. AV is equal to lambda V. This is the component of eigenvalue equation. And it will only stretch under A. The singular values of a matrix are the diagonal entries of A, the eigenvalues of A, eigenvectors of A transpose A, square roots of eigenvalues of A transpose A. So this will be the square root of eigenvalues of A transpose A. So there is a 3 by 3 matrix C which has eigenvalues 1, 2, 3. So there's a 3 by 3 matrix C and the eigenvalues are 1, 2, 3. N is 2C plus 3y. Then what is the eigenvalue of N? Give 1 second to do this. So if lambda is the eigenvalue of, then eigenvalue of alpha c plus or c, lambda is the eigenvalue of c. Then the eigenvalue of alpha c plus beta I is alpha times lambda plus beta. So here lambda is the eigenvalue 1, 2, 3. So you take each of the value and multiply by 2 and add by 3. So first lambda is 1, 2, 3 and alpha is 2, beta is 3. So then you take each of them. So 2 alpha, sorry, 1 into 2 plus 3, which is 5. Then 2 into 2 plus 3, 7. 2 into 3 plus 3, 9. So it is 5, 9. So it is A. The solution to the system is what is the solution to this system? Yeah, so it is B. You can simply substitute the values in the for x1, x2, x3, and then when you substitute these values, you can see that this one will satisfy. This one. This pair of vectors is orthogonal. So two vectors are orthogonal if their dot product is 0. So it is 1, 0 and 0, 1. The others will not have their dot product equal to 0. So there is a pair coin and it is tossed right. X is a random variable that represents number of heads. What is P of x is equal to 1? What is P of x is equal to 1? Yeah. So it is 2 by 4 or 1 by 2. So when you toss the coin twice, you will get head, 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 tail, tail, head, tail, tail. So the events with exactly one head is head, tail and tail, head. That is 2 of them out of the 4 of them. So it is 2 by 4, that is 1 by 2. P of A is equal to 1 by 2. P of B is equal to 2 by 3. P of A union B is equal to 5 by 6. What is P of A intersection B? P of A intersection B is equal to P of A plus P of B minus P of A union B. That is 1 by 3 plus 2 by 3 minus 1 by 6. So this will be 2 by 6. Machine A produces defective items with probability 0.05. Machine B produces defective item with probability 0.08. assuming independent. What is the probability that items from both machines are defective? 0.13, 0.003, 0.004, 0.065. Machine A produces defective item 0.05, B 0.08. That is independent. Then what is the probability that items from both are defective? Yeah. So for independent event, it will be P of A intersection B is P of A into P of B, and here it is 0.05 into 0.08, which is 0.004. In a study of 1,000 patients, 400 have hypertension. And the typing is HT, and 600 have diabetes. Among ST patients, 250 also have diabetes. What is probability of diabetes given hypertension? 0.425, 0.525, 0.625, 0.725. So probability of diabetes equal to 1 given hypertension is equal to 1. Both are there. So given hypertension is there, what is the probability that someone has diabetes? So that we can write as joint probability by P is equal to 1. So in this case, this is 250 because 250 also have diabetes. So 250 has both diabetes and hypertension, and fully hypertension is 400. So it is 250 by 400, which is equal to 0.62. A machine will make 60% of item and the defect rate is 2%. Machine B makes 40% of the item and the defect rate is 5%. An item is found defective. What is the probability that item came from B? 0, 0.50, 0.70, 0.60. So we have to use Bayes' theorem here. So by Bayes' theorem, what we have to find here is probability of B given the item is defective. So that is given by B given B into probability of B divided by probability of D. And probability of T given P, probability of B is the probability of B. First we have to calculate is equal to 60% of the items have a defective rate of 2. So that means 0.6 into 0.02 plus 40% have 5%. So 0.4 into 0.05. So that is about 0.032. Then probability of B given D is equal to 0. D given B, that is 0.05 into probability of B is 40%. So 0.40 divided by 0.032. So this is around 0.625. The binomial distribution. PMF is given in X hat distribution P of X is equal to 1 is 0.2. P of X is equal to 2 is 0.3. P of X is equal to 3 is 0.3. P of X is equal to 4 is 0.2. Find expectation of X. 2.5 to 3.0, 2.7. So this is the distribution. What is the expectation of X? Yeah. So expectation of X is this 1 into 0.2, 2 into 0.3, 3 into 0.3, 4 into 0.2. So this will be around 2.5. For the same X here, what is variance of X? So the expectation of X, we know it is 2.5. Then what is variance of X? So variance of X is expectation of X square minus expectation of X, the whole square. So now you can find it. So expectation of X square is 1 square into 0.2 plus 2 square into 0.3 plus 3 square into 0.3 plus 4 square into 0.3. So this will come to around 7.3. Then expectation of X we already know it is 2.5. Then expectation of X the whole square
will be 6.25. Then variance of x is this minus this, so 7.3 minus 6.25. 1.05. If expectation of x is equal to 3, what is expectation of 2x plus 5? So there is this linearity of expectation. That is expectation of ax plus b is equal to a times expectation of x plus b. So just directly apply that. So 2 times 3 plus 5, which is 11. If variance of x is equal to 4, what is variance of 3x plus 2? 36, right? So variance of ax plus b is a square times variance of x. B don't affect the variance, so it's only a. So that a will be squared. So then here it is variance of 3x plus 2. So that is 3 squared into variance of x, which is 4. So it is 30. In gradient descent, the weight update rulers W is equal to W into times 4 for the W. W is equal to times 4 for the W is equal to W times 4 for the W. W is equal to alpha. Yeah. So gradient descent moves in the negative gradient direction, which is the steepest descent. So W is equal to W is alpha times dou J by dou W, where alpha is the learning rate. Yeah, I corrected that. Sorry. What does the learning rate alpha control in variant system? The step size of each update, the loss function, the number of features, the direction of the update. So the learning rate alpha, it controls the step size. When it is too large, it will result in oscillations or divergence. When it is too small, then it will result in very slow convergence. So choosing the right alpha is very important. So perfect is equal to x square. What is the gradient? Dou f by dou x at x is equal to 3. Yes. So dou f by dou x is 2x. When x is equal to 3, then you get 2 into 3, 6. So it is 6. So for a convex loss function, the gradient descent uh, may get stuck in local minima, or it always diverges, or it always converges, or it is guaranteed to find local minima with suitable alpha. Yeah. So it is guaranteed to find global minima with suitable alpha. Its activation function has the derivative sigmoid into 1 minus sigma. So it is sigmoid. So linear regression minimizes which loss? Yeah. So it is the mean square error MSE. What is the range of sigmoid? Minus infinity to infinity, minus 1 to 1, 0 to 1, 0 to infinity. Sigmoid is given by 1 by 1 plus e raised to minus z. So when z is like positive infinity value, then e raised to minus z will be 0. So it will be 1. And then z tends to minus infinity, this will tend to 0. Then z is equal to 0, it will be 0.5. So it is between 0 and 1. The state is not linearly separable and requires multiple hidden layers to implement. It's XOR because we have already seen this, but it can't be separated by a layer. Logistic regression with OR gate, W0 is -1, W1 is 2, W2 is 2. What is the output for the input 0, 0? So is it is equal to W0 plus W1 into the first input, which is 0, plus W2 into the second input, that is 0. So it is just W0 and that is -1. So then you have to, so this is logistic regression. So whatever output you get, you have to pass it to the sigmoid layer. So it is sigmoid of Z, it is sigmoid of -1. So this will be around 0.27. So this is a value that is less than 0.5. So it will predict class 0. Sigmoid is also known as logistic function. The naive assumption in naive Bayes refers to the classifier being simple to implement, features being conditionally independent given the class, using only one feature, assuming equal class priors. So the naive Bayes make a strong assumption that all the features are conditionally independent given a class C. So this is what dramatically reduce the parameters that are needed in the algorithm. So here the features being conditionally independent given the class. So for text classification, what is the key limitation of null base? What is the key limitation of null base for text classification? Because in text classification, if you take the words are very highly correlated. For example, if you take feature independence itself, feature and independence, they are correlated. So the independence assumption will be violated when we use it for, I mean, it has to be violated for text classification. But then still, in practice, if we see, naive Bayes performs comparatively good in all the problems due to its simplicity. So again, this is something that has been like it works. Like in most of the time, it is used as a baseline for comparison with the other classifiers. So it's a very simple model that can be used. So support vectors in an SCM are all training points, the data points farthest from the boundary, all misclassified points, data points closest to the decision boundary. So support vectors are the data points for which this y into w transpose x plus b is equal to 1 exactly. So they lie on this margin hyperplane, and these are the only points that determine the decision boundary. All the other points can be removed without change. So the answer is data points that are closest to the decision boundary and those that lie on the margin. The matrix factorization that is mainly used in PCA, typically used in PCA, QR, MU, STD, FLSD. This SVD, SVD is commonly used, typically used with PCA. In the GAN framework, the key neural networks that are used are called as generator and discriminator. Generator will learn to produce some data from the noise, and the discriminator will learn to distinguish between real and fake data. And this generator will always try to fool the discriminator, and the discriminator will always try to detect this G. The bottleneck layer in autoencoder refers to the layer with largest number of neurons, the layer where dimensionality reduction occurs, the layer with slowest computation time, final output layer. So the autoencoder will compress input through an encoder to a very lower dimensional latent code X, that is called as the bottleneck. Then from that X, it will reconstruct the input via a decoder. So the bottleneck layer is the layer where the dimensionality reduction occurs, or it is called as the latent force. Yeah, so today we were mainly covering the questions from the previous week. This was an extra session. So tomorrow the actual session will be there from 7 p.m. to 9 p.m. Thank you all for attending today's session.